This video is to explain about Kerberos, which is a ticket-based authentication service. Kerberos is named from Greek mythology, the three-headed dog which guards the gates to the underworld. In mythology, the dogs face inwards, preventing escape. In Kerberos authentication, it is used to control access to resources. Kerberos is a ticket authentication methodology. After authentication is complete, by proving identity and checking the user is authorized, then Kerberos issues tickets which can be used when requesting access to resources. Kerberos provides single sign-on, allowing users to log into multiple systems with a single username and password. It also protects logon credentials using symmetric cryptography. In this diagram, we have a user that wants to access the resources on this resource server. Rather than authenticate directly with the server, this will use a Kerberos server. Authentication is provided by the Key Distribution Center. This is often a single server, although it could be split across different servers, especially for larger networks. The Key Distribution Center is the trusted third party that provides the authentication. The Key Distribution Center provides the authentication service and the ticket granting service. As I said, these can be on the same or different servers. The database of accounts will also be stored at the Key Distribution Center. This is often based around Microsoft Active Directory. And here's an explanation of how Kerberos authentication works. The user enters their username and password. The username is encrypted using AES, which is then transmitted to the Key Distribution Center. The username is verified by the Key Distribution Center, who then generates a symmetric session key, which will be used by the client and the Kerberos server. The session key is encrypted with a hash of the user's password. The Key Distribution Center also creates an encrypted timestamped ticket granting ticket. The encrypted session key and the ticket granting ticket are sent back to the client. The client installs the ticket granting ticket, which it can use until it expires. The client uses the hash of the user's password to decrypt the session key. If the password is correct, then the session key can be extracted. This way, the password can be verified and it was not sent over the network. The client now has a ticket granting ticket, but now needs to request another ticket to get access to the resources on the server. As long as the ticket granting ticket, TGT, is still valid, i.e. it hasn't expired, then the client can use the TGT to request the ticket without needing to re-authenticate. The user sends the TGT to the Key Distribution Center with a request for the resources needed. The KDC, Key Distribution Center, verifies that the TGT is valid and checks its access control matrix to verify that the user has sufficient privileges to access the requested resources. The ticket granting service then generates a service ticket, which is sent back to the user. The user can now send a request to the server asking for access to those resources, and it sends that along with the service ticket. The server verifies the validity of the ticket with the KDC, and the server can then open a session with the client and begin communications. So there's a few challenges to the use of Kerberos. One is that the Key Distribution Center, the KDC, can be a single point of failure. If that is unavailable, then it means that multiple services may be unavailable to the clients. Another concern is that if the KDC is compromised and its secret key is obtained, then that is the secret key for the entire network and the network is compromised. Another challenge is that the client and the servers need to have time synchronization. It's recommended this is done using NTP, the Network Time Protocol. There are some exploits that have been used in the past against Kerberos. These are some of the ones you should be aware of. I've not provided details of how to exploit these. It's just a summary of some of the vulnerabilities to be aware of. Overpass the hash. This is an alternative to the classic pass the hash vulnerability. And through it, an attacker can request a ticket granting ticket with the user's hash and use this to access network resources. This is sometimes known as pass the key. Pass the ticket is where attackers attempt to harvest tickets which they can then inject to impersonate a user. The silver ticket vulnerability uses the captured NTLM hash to create a ticket granting service ticket. A golden ticket is if the attacker obtains the hash of the Kerberos service account, and then they can create tickets at will. For a Kerberos brute force attack, the attacker attempts to guess passwords using brute force. It can also work on usernames, as Kerberos responds differently if a username doesn't exist. ASR EP Roast identifies users that don't have pre-authorization enabled. This allows attackers to send the authentication request and get back a ticket granting ticket encrypted with the hash of the user's password, and this allows them to attempt an offline attack to decrypt the password. And the final example here is Kerberos, which collects encrypted ticket granting service tickets, which can then be attacked offline. In summary, Kerberos is a ticket-based authentication service based around the key distribution center, which can be a single server or can be across multiple servers. It uses symmetric encryption based around AES, Advanced Encryption Standard. It's often used with Microsoft Active Directory. I hope you found this video useful. If so, I'd appreciate it if you could give the video a like and let me know in the comments. Don't forget to subscribe and click on the notification icon to see my future videos. Thanks for watching. I look forward to seeing you in a future video.